Dear civil engineers, welcome back to School of Civil Engineering. From this lecture, we are just going to design a 10-story building with ETABS 2020. And here you can see this is our floor plan. Okay, and this is our underground or basement floor. Then here this is our beam column layout, and with respect to this layout we'll draw or we'll complete our design. So let's start. And before starting, if you're new to our channel, then don't forget to subscribe to our channel and also press the bell icon so that you will get all updates ever first. Now first of all, I'll open here ETABS 2020. Okay, this is a new software with a very new look, and you know this software have released several months ago. Now after opening that software, we'll start working. So this is a software ETABS 2020. First of all, I will define everything what we need actually. Now I will click here for new model, and they have three options. First, use saved user default setting. That means if you work previously with any default setting, or if you want to work with software default setting, then you have to select the first option. And the second option means already you have worked and you have a saved model from where you will be able to transfer your setting in your new model. But I will use that on. This is the best setting for me especially. So here, use built-in setting with display unit. So what will be your display unit? I am using US customary here, and reason for default materials, at which reason actually I am just going to use United States. Then steel section database. What will be the steel section database? Actually, as we are going to design concrete building, that's why the steel section database and steel design code are not required. Now I'll select from here concrete design code. From here I will select the latest one, ACA 31819. I'll click here. You can select 08, 11, 14 and 19, and they have any other software code here available, so I'm just going to use that one. After that I'll click OK, and now I'll don't do anything here because I'll change that after defining everything what I need actually. So I'll select here grid only and then go OK. Now this is our interface, and after that I'll go here define, and first of all I'll define material property. So here I'll click, and they have some default materials property. You can use that. Otherwise I can click here add new material. I will add new material. So region United States, you can select any other region from here. Then materials type, first of all I will define the rebar, and standard they have some standard like ASTM A615 and A706. So if I select that one, then see here the three grade are available, grade 40, 60 and 75. And if I select this option, then only 60 grade available. So I'll use user default. Okay, I'll use user default, and I'll consider as per my requirement. I'll click OK. Now here I'll just change that name FY, the value of FY 72.5 KSI. That means 500 megapascal river I am taking. Then a specific weight density 490. Modulus of elasticity default because they have no change in unit weight and modulus of elasticity. Okay, then coefficient of thermal expansion A, this is also default. After that I'll go here design property data. So here what will be the grade actually? I'll change that name close, I'll select that, and I'll go here and I'll just provide that value here. After that, maximum yield strength FY. So what will be the maximum yield strength here? 72,500. So 72,500. Now I'll copy that value. And what will be the minimum tensile strength? So if you, if your lab test data are not available, then you will just multiply that minimum yield strength or FI value with 1.25. That means 72,500 into 1.25. Enter. Again, here for FYE, for expected yield strength, 1.1 times of FY. I'll just provide that value into 1.1, then enter. And FUE, expected tensile strength, will be 1.1 times of tensile strength FU. This is so into 1.1 times. That's it. Simply I have defined that materials, river materials properties. Then okay, then okay. Clear? After that, again I'll go add new materials property. Everything will be same, just here concrete, and that will be user defined. Then okay. Now from here I will consider 5,000 psi concrete, 5,000 or 4,500 psi concrete, and here concrete. And after that it will be isotropic. From here, a specific unit weight density. So what is actually, they have some issue. So unit weight per unit volume. So if you use brick stone, then it will be 135 lb per feet cube. But if you use a stone aggregate as a concrete or to cast concrete, then we'll use 150. This is very critical. Okay, so I am going to use concrete, stone as a concrete, concrete materials, then it will be 150. And for the modulus of elasticity, what will be the modulus of elasticity? As per ACI, modulus of elasticity will be 5700. Okay, that means 57,000 root over FC prime, then into root over FC prime. That means 4500, sorry, 4500 root sine 0.5. Clear? Or otherwise you can calculate 5700 into root over 4500. Then done. Here I have completed that. Poisson's ratio and every data will be same. Just I'll go here, and from here I'll change 4500, and I'll change that name and actually 45. That's it. Then okay, then okay, done. So I have defined the two types of materials. Then I'll go okay. After that I'll click here define, then section properties, sorry, I'll take it here. Sorry, if you need to change that, actually you can change that. I'll close it. I'll close it, and from here I can add new windows. Just see here in new windows, nothing to worry about that. Now I'll go, I can define section properties, then frame section. So they have many section available, it's not required. I'll click here delete multiple. I'll select all of them, delete. I'll select all of them except one, expect one, then okay, just see that one are available. So now I'll go here, add new properties. That will be concrete section, concrete rectangular section. So first of all I'll take column, and what will be its size? It will be 10 C into 15 into 15 for our corner column. Okay, 15 into 15 for corner column, and materials property, that will be 4500 psi, and from here 15 inch into 15 inch. After that, they have property modifier. I will use that property modifier later. Now I'll go here for reinforcement, and from here must select FI 7 to 5 and FI 7 to 0.5. From here PM to M3 design, that means for column, and it will be rectangular, and we will use confinement bar as a ties, and clear cover for confinement bar, that will be 1.5 inch. Done, and no need to change anything. Just here reinforcement to be designed for design, and if you provide here reinforcement, then you will provide here reinforcement to be checked. I mean, software will check the reinforcement is okay or not with respect to provided data from here. Then I'll go click OK, and after that I'll click again OK. Now I can delete data. Yes. Okay, now again with respect to this data, I'll take copy of properties. Then here see 15 into 18. I'll take several section 15 into 18, and everything is okay. Just here 18, and no need to enter here 15 into 18. Okay, then again add copy of property, add 15 into 21, and here just 21. That's it. And okay, and again now I will define our beam section. So add new properties, then concrete rectangular section, and from here beam. Okay, first of all I'll select grade beam 12 into 18, and from here 12 into 18, and from here you have to must select 450 psi, and for reinforcement I'll select 72.5, and that will be beam, and your effective cover 2.5 and 2.5. It's okay. Actually, what is the meaning of effective longitudinal and river group centroid? I'm covered to longitudinal and river group centroid. What is the meaning of that? That means the distance from outer surface of beam to centroid of that longitudinal reinforcement. Okay, and if you need to provide any reinforcement area override for ductile beam, then you can provide here, but no need for my case. Then I'll go okay. Sorry, for grade beam, actually for grade beam we have to provide almost 2.5 inch clear cover. That's why I will consider total 2.5 inch for clear cover, and for confinement bar and for the radius of our longitudinal river I'll consider 1. That means 3.5, and here 3.5. Actually you can provide that value 3.5 and 3.5 for grade beam, and 2.5 for normal beam or floor beam. Then 12 into 18 I'll consider with that data first time, and after that if need I'll change. After that I'll take copy of that property, then floor beam 12 into 18 4.5, just 12 into 18, it's okay. Also just here you have to change 2.5 and 2.5, that's it, and everything will be same. Okay, then copy that one. Okay, again I'll take add copy of properties, and 12 into 21, and here 21. I'll consider only the two section now. Okay, and this is for our floor beam. Okay, now I'll take another copy of properties, then stranger beam, that means the beam below or mid landing of a staircase, and everything will be same. I'll just 12 into 15 or 10 into 15 for the first time, 10 into 15, and here 10 into 15. Then okay, so everything is, I'll just check on thing. Yes, everything is okay. Then okay, so we have defined the required section for initially, I mean for initial situation, which types of section we required, just to have defined, and after analyzing, if we need, we'll change that. I'll click OK. Now here define slab section. I'll delete that on, and I'll just modify that on modify. So for slab section, I'll consider 5-inch slab, 5-inch, and from here I'll change our concrete properties, and it will be shell thin, and slab section will be 5-inch. Okay, then another size of our slab, slab thickness for our stair gauge, I'll consider that is for 6-inch. Stair slab SB for 6-inch, and I'm just considering 6-inch. Then okay, then okay. Now I'll go section properties, and no need all section, I'll change that reinforcing bar size. So here just see the bar ID are in number 2, 3, 4, 5. So I'll clear that, and I'll add a common bar size, and SI from SI unit I'll just take it as a millimeter. Okay, you can change that as per your requirement. Then okay, after that I'll go here, and everything is okay. Now just actually we no need to do anything here. After that we'll go for mass source, but after defining load pattern we'll go for mass source. Now I'll click here for load pattern. So which types of load we require actually? So for dead load, yes, dead load with self weight multiplier 1 already predefined. For live load with self weight multiplier, this is also available here, but we need as per ASCE loading system. Okay, so if I just open, so here this is load combination effect for strength design method, okay, or USD design method actually. So here we have basic combination onto 7 combination. Clear? Just see here we have basic combination for on to 7, and now we'll define our load pattern first, then we'll go for load combination. So actually the defining load combination is quite important, and this is very difficult actually also, because you have to maintain many things to design or to define your load combination. Okay, so in this lecture I will try to discuss everything about our load combination, because we have to take some decision as per our code. And here just see they have another criteria for our earthquake effect. We'll maintain that on, okay, horizontal effect and vertical effect, horizontal earthquake load and vertical earthquake load. Okay, so we'll do that. And even here actually they have another issue. The structure of seismic design category C with plant irregularity type V and seismic design category D shall be designed for 100% of horizontal seismic force in one principal direction combined with 30% of the horizontal seismic force in the orthogonal direction. Possible combinations are here 100% in x direction plus minus 30% in y direction and 30% in x direction plus minus 100% in y direction. Clear? So then first of all, to do that, first of all we have to find out our structure goes under category 3 C or category D, design category C or D. Okay, and with plan irregularity V, we have to consider that. Okay, so we'll do that. Firstly, we'll do that. Actually, this is as per BNBC 2020, and this is similar to ASC 705 and ACI 318. So nothing to worry about that code, because this is totally similar with the code of ACI and American code. Now here, first of all, we need live load, and if we go for combination, if we go for this, just see here LR, that means row of live load, and then row of live load. So I'll just go here. I'll consider that live load as a L live load F, that means for floor live load, and I'll just click and modify. Just see it's modified. Then LLR live load for roof, I'll add that on. Then I'll go for floor finish with super dead load, then add that on. Then I'll go for partition wall, okay, for super dead load, then add, and it's okay for all the steps of load. Now I'll go for earthquake load in X direction, and that will be seismic, and here I'll consider ASC 705, ASC 7010 or 7005, no problem. So I'll consider 7010, and also you can consider 716. It's depend on yourself. Now I'll click here for ASC 7010, or okay, I'm considering 705 because this is very similar to our national code. Done. Then add that combination, and this is same for y direction. Done. And E, then WX, then from here wind, and I'll consider ASC 705. Then add new and WY, same. So just see we have defined that, and after that, after completing our model and doing everything, we'll define that required data. Clear? I'll just close. I'll click OK. Now I'll go for mass source. So I'll go for modify, and you know that I'll uncheck that to 1, and I'll click a specific load pattern, and from here include lateral mass and lump lateral mass at Storey level, and they have a specific combination as per our code and as per ASC 705. This is for seismic weight mass source. We have to consider 100% of permanent heavy equipment or retained liquid or any imposed load sustained in nature shall be included as a total dead load. That means we have to consider total dead load of building or a structure, including partition wall and applicable portion of other imposed loads listed below. And for live load, we'll consider 0.25, that means 25% of live load if our provided live load is less than 3 kilonewton or equal, or we'll provide 50% of live load if our provided live load are more than 3 kilonewton per square meter or 60 psf. Clear? So as a 10 story structure in row, I'll provide more than 3 kilonewton in, I mean as a live load. Okay, I'll provide 100 psf, that means 4.8 kilonewton per meter square almost. That's why I'll consider 0.5 times of live load as a factor. I'll just go here, and from here I'll consider dead load with 1, done. Then floor finish with 1, I mean this is also our, and partition all, this is also our dead load. And for live load floor 0.5, and live load row 0.5. That's it. Clear? Done. Then I'll click OK. I'll click OK. So we have done defining almost everything that you need for first time, and after that we'll define, and here we can take our that live load, I mean the every load we have already defined. So here the every issue with name, we have defined that live load as a live load floor. So I'll just go here, modify, and just say here LLF. I'll also give its name LLF. That's it. Okay, so done. Everything is okay. See, everything is okay. Now I'll go okay. We have defined everything what we need initially. Now we'll go for live load. So we'll go for live load in next lecture. And if you hear, that means you have liked our video very much. So I'll request you obviously subscribe to our channel, and also support us by joining as a member. And if you love me, then you can join as a super fan member. Also you can give us super thanks from our like button. So thank you very much. We really appreciate your love and kindness. Thank you very much.